We did these in class today, but I'll go over one again. They're worked examples to sort of solve some problems. So look at the first one. It says log base 10 of 3x plus 1 is equal to 2, find x. So you've heard me say this a few times. What power is 10 raised to give you 3x plus 1? And the answer is 2. So obviously 10 to the power of 2 is equal to 3x plus 1. And then you just solve that. You get 100 is equal to 3x plus 1 and so on. So that's the first bit you've got to get. Let's have a look at the second one. Log base 2 of x plus 3 is equal to log base 2 of x plus 9 to be squared. Well, the same as in any equation. This means that x plus 3 is equal to x minus 9 to be squared. Okay, we can just drop the log notation. For example, similarly, if I were to say something like the square root of x squared plus 7 is equal to the square root of 3 plus 5x, I can then say that the x squared plus 7 is equal to 3 plus 5x because I can square both sides and get rid of the square root. So equally, I can get rid of the log notation here as well. So I'm left with x plus 3 is equal to that, and then I just solve that. So using the law 2 of logarithms, I have log base 2 of x plus 1 minus log 2 of x minus 1 is equal to 1. I can then divide the inputs to these logs like in such a way like this. So log base 2 of x plus 1 divided by x minus 1 is equal to 1. To test that, I'm going to go, let's say log, I'm going to assume it's base 10 of 100 minus log base 10 of 10. Well, that's equal to 2 minus 1 is equal to 1. Okay, and what they're saying that this I can then do, that's equal to log of 100 divided by 10. And that's equal to log of 10. And that indeed is equal to 1. So just using my little example here, I can see that that has actually worked. I can actually divide. So log base 2 of x plus 1 over 1 minus 1 is equal to 1. Now, what power is 2 raised to? What power is 2 raised to give you this here? And the answer is 1. So 2 to the power of 1 is equal to this. Okay? So 2 to the power of 1. And then you just cross multiply, or you multiply by the x minus 1 on both sides. So I'm going to get x plus 1 is equal to 2 multiplied by x plus 1. X minus 1. And then you get a nice simple equation and you solve it. Very good. Now I'll do another couple of examples from the homework to get you started on each of the types of questions on the next page. Okay, let's have a look at this. Using one of my log laws, I can say that 3 log 5 is equal to log 5 to the power of 3 plus this one here, 2 log 7 is equal to log 7 squared minus log 3 squared. It's one of the log rules. I'm not sure which one it is, maybe 2 or 3. So that's equal to log 125. And by the way, these are all base 10. Plus log 49 minus log 9. Now, okay, the next thing I can do, I can recognize that one of my log rules means that because these are added, I can multiply them. So I'm going to get log 125 times 49. And then we're subtracting log 9. And so now because I'm subtracting, I can say that's equal to log 125 multiplied by 49 divided by 9. Okay, so that should give me, now by the way, the examples you've got to do are going to work out much nicer than this. I just threw in the big numbers. But it's quite interesting actually. Let's work out and see. I'm going to plug this here into my calculator and plug this into the calculator. And they better work out. So, okay, I just did this one here and I got 2.83. Okay, now let's see if I get the same for the other one. I'll do it online. Log, I'm going to have then this 125 multiplied by 49 and all divided by 9. Moment of truth. Yes, 2.83. So it does work out the same. So that's what question 8 is going to be like. The question says, use the laws of logs to express as a single logarithm. Okay, so have a go with some of those. That's question 8. Question 9, we'll do on the next page, is solve for x. All right, so What power is 2 raised to give myself 5x plus 1? Well, the answer is 4. So 2 is raised to the power of 4. So 2 to the power of 4 is equal to 5x plus 1. 2, 4, 8, 16. 16 is equal to 5x plus 1. So 5x is equal to, as it happens, 15. I just made this one up, by the way. I didn't expect it to work out so nicely. So x is equal to 3. If you plug the answer back into this again, I'm going to use my calculator. It's log base 2 of 15 plus 1 is 16. Yeah, now that I'm looking at it, it is 4. So that's the correct answer. Okay, that's question 9. So that's what you do with those ones. And the last ones are question 10 I've asked you to have a look at. So they are solved for x. So let's have a look at one of those on the next page. Okay, I made this one up as well, so it probably won't work out as tidy as the other one. But let's have a go anyway. So we see there's a negative here, a negative between these two. So that means we can divide our logs because they have the same base. So it's going to be log base 3 of 2x plus 7 divided by x minus 2. And that's equal to 1. Now we have a single log. So now we can say, excellent, 3 to the power of what number gives me 2x plus 7 divided by x minus 2? Well, the answer is 1. So 3 to the power of 1, which is 3, is equal to 2x plus 7 over x minus 2. And that means that 3 times x minus 2 is equal to 2x plus 7. And then I'm going to get 3x minus 6 is equal to 2x plus 7. That means x is equal to 13. Okay, what I did there was I subtracted minus 2x from both sides. So this disappears. I'm left with x over here. And then I add 6 to both sides. X equals 13. Always nice to see if that works. So let's say x equals 13. So again, I'm going to go log of 3 of 2x plus 7 is 13. Let's go back again, 13. So that's equal to 13 is 26, 33 minus log base 3 of 13 minus 2 is 11. And the answer is 1. Okay, so there's 3 sample questions for you. I'll post this now, and thank you. Good luck.